Welcome everybody on a final class for this module for C++ London Uni. So today we will be talking about interviews questions. After that, obviously, we'll move to the next module, which is test-driven development. But before that, let me introduce us. So you know who you're dealing with. My name is Tom. I'm one of the hosts. This is Tristan, another. It's one of our main teachers. And where's the empty chair? There is Oliver. He quietly disappeared in a very British fashion, so nobody noticed him. Now we meet. We try our best to meet every single week on Tuesday to run a lecture. How do I get my slides? So, before I go there, first of all, I would like to say a massive thank you to the Binary District and PrimalBase for again hosting us in this really, really cool office. I honestly enjoyed the view, and I hope as everybody. So, without their support and providing us with the space, which is free of charge, we would have not be able to run the class. So massive thank you to PrimalBase. Please do tweet about them and mention them in social media as a way of saying thank you from us. Again, thank you, a massive thank you to our patron sponsors. You guys making a massive difference. Thanks to you, we can purchase microphones and so on, things like stickers and so on. So your contribution do make a difference. So thank you very much for that. We would like to have a special thank you to Władimir Gladun. He offered and helped us to produce the first batch of our stickers. I did it correctly, haha! So, if anybody found some stickers, please come to me and I will share them. So, thank you very much, really appreciate it. So, we're still looking for home. We have somebody who is trying to help us in one of the bigger businesses, but if you hear anybody, please do help me, and especially if you want the future classes to be smooth and without any gap, I honestly would really appreciate some help, because you know I'm feeling like I'm banging quite literally on a wall. The more I talk to the same people, the less responses I get. So you know, guys and girls, if you know anybody who can offer us some kind of space, quiet, with couple of chairs, desks, internet connection, large screen or projector on Tuesday evening, do let me know, because we can really use the space. Obviously, we can't pay because we are pretty much without any sponsor. So, but if somebody got us free space and wants some publicity, we're happy to cooperate with them. Now, where are we? As I said, we are just finishing the core module, the core development skills. This is pretty much last class, and as I said, then we'll go to test-driven development, which will take approximately 5 to 6 weeks. And after that, we'll go to introduction to templates. After that, assuming we don't have any gaps, you know, where we cannot find the space, we'll basically start a new course, Hello World, and so on. So please do spread the word. So especially for somebody who is new and would like to learn from the beginning, please do let them know that at some point the new course will come live. And what's really important as well for you, if you run through the course, you're still welcome to continue. You know, always learning something new. I'm doing this a couple of times already. So even though some of the beginning classes, they're very easy, but it will open your eyes to the new stuff. So, you know, you're very welcome to continue. So now, how do we work? So there's 2 meetings, yes, with us. Tuesdays, which is today, it's a lecture. So Tristan or Oliver or a guest tutor will try to explain some very complex material in extremely simple way. To such a degree, you will think this is the most easy subject ever. Why so much fuss about C++? There's nothing more easy. But then you sit down and you try to use that, and you realize actually it's harder than these guys explained to you. So you definitely want to have some practice. And we got you that on Thursday. Assuming there is people who wants to come, yes, then one of the, mostly Oli, will sit down in like a coffee shop. We got like a place where we sit down. You buy yourself a coffee. You can buy one for Oli. You sit down, and then you have pretty much almost one-on-one for free, which is, I suspect, amazing. So if you want to have increase your performance as a developer and actually speed up and become a better developer, please do come on Thursday sessions. Now, if anybody is missing a license or would like to get a Sea Lion license, Sea Lion is basically a commercial product, but because of our friendship with Phil Nash and JetBrains, they offered for all our students a 6 months free license. So send me an email. I will send you back the license. And if you continue with us even after the 6 months, you'll get another one. So it's a pretty good way of getting a free license for Sea Lion, which costs something like, I don't know, £60, £70 or more. Anyway, amazing product for free for us. So if you need it, let me know. Because this is a free event, we need some support as well from you. Yes, we're giving you lessons, we're giving you the knowledge, but we need from you a little bit of help. Patreon, if you decide that you benefit and you work in a fully, you work as, let's say, at some profession and you get money every week, you might consider helping us and pay a couple of pounds. You may be in a position to, let the business where you work, that they could potentially sponsor us. We're open to all sorts of cooperation. Just let them know. And finally, after the meetup, we are going always to pub down there, Biershanke. So make sure that Oliver and Tristan are very well looked after. They got some nice warm food and some drink for their work. As you can imagine, to run the class, it's approximately 2-3 hours. To prepare the class, it's another 2-3 hours or more, potentially more. So please do help them, help me keeping them happy, so they'll come back next week. Finally, do share about us on the social media. Make sure that Twitter and LinkedIn, Facebook, Meetup, and any other place is a bit of buzz about us, so people know that actually what we're doing. So there is more people who will join us. This way, actually, you can help us quite a lot. And finally, that's all pretty much from me. Please do check the website, because if we change anything, you'll find there most likely. That's all from me, and I'm passing you to way more interesting talk.
All right, thank you, Tom. If I can get my mouse working. And we're on. Awesome. Welcome, everybody. This is session 7 of our core developer skills module. So we've got quite a few people tonight, which is awesome. Hello to anybody who's new. You've come right at the end of one of our modules, but that's okay, because what we're doing tonight is, I'll go into it in a minute, but it's kind of standalone and not really, you don't have to have been to any of the other sessions for this module to really understand what's going on. So hopefully we'll give you a good taste of what we do here to an extent anyway. Before we begin, just my usual slide on feedback, because we do like to hear from you. The easiest way to talk to us is via Slack, chat messaging app. Just go to that URL you see on the screen, slack.cpp.al. It'll redirect you to the right website. It's got a little box, put your email address in, it'll send you an invitation, and you can come and join the CPP Lang Slack, and in there you'll find the #CPP London Uni room where we all live all of the time because we've got nothing better to do. But no, seriously, that's by far the easiest way to talk to us. If you've got any comments, questions, things you'd like to ask, things you'd like to ask everybody, get on Slack, please do. Okay. So this has been a rather different module to what we normally do. This core developer skills module that we've been doing the past few weeks, because we haven't really done any new C++, which has been a bit strange. So we've looked at things that are to help you become a better programmer. Generally, I mean, not specifically C++. I looked at using Git on the command line, how Git works. We looked at GitHub, which everybody uses these days. We looked at CMake, which is a build system that's particularly used for C++ projects. Last week, or in fact the week before, the last session, Ollie went through using continuous integration systems. So we've done a few different things. If you weren't here for any of those, all the videos are on YouTube. Go to our YouTube channel, youtube.com/CPP London Uni. You can find all our videos there, including today's. And yes, so what's on the menu for today? Well, today we're going to be talking about interviews. Horrible, dreaded things that everybody hates, but unfortunately a fact of life. If you want a job. And so it's going to be sort of a two-part session today. First of all, we're going to have a bit of me talking just about interviews and some interview tips and what you can expect and how you can help yourself prepare for them. And then we're going to have some practice exercises, and I'll say a bit more about those when we get to them, but meant to be more of an interactive thing, asking questions, putting people on the spot, asking them tricky questions, getting into practice, thinking on their feet as you have to in a real interview. So that's today's agenda. So let's crack on with part one, the coding interview. So what's the point of an interview? To see if someone's suitable for a job. And fit in with your team. That is great, because that's pretty much what I said. Firstly, can this person do the job? Do they have the skills, the experience, or are they just going to be, sitting at a desk for 8 hours, not knowing what's going on? Can they do the job? And secondly, is this person a good fit for our organization? You agree? That's sort of...
You could say, does the person have the potential to do the job? Depending on what level.
Oh, will the person be able to do the job would probably be a better way of putting it. Yes, that would probably be a better summary. So does that sound reasonable? That's why people have interviews. Unfortunately, it's not just a matter of sending your CV and they send you a job offer next week. People want to talk to you. It's really annoying. So of these two, the second part is a bit more, comes down to what people call soft skills, although other people hate that term. Sort of interpersonal skills, how well you get on, how well you present yourself. Basically trying to make the other person like you. That's a life skill, right? That's not a specific C++ interview skill. It's not even interview skills in general, really. It's a life skill. And not really something we can help you with today. However, I will say, usually these things open with a bit of chit-chat, a bit of general chat before launching into all the technical stuff. You have this opportunity, tell us a bit about yourself. Practice it. Get used to talking about yourself. Get used to selling yourself. Not too heavily. I mean, you don't want to come across as sort of arrogant either, but get used to selling yourself a bit. Be comfortable. Practice this sort of opening spiel that they will inevitably give you. It can be a good thing. The other thing is that you will inevitably be nervous, because if you aren't nervous for an interview, you're not a normal human being, really, or you don't really care about the job. Yes, you're going to be nervous, and people get nervous. They deal with it in various ways. They either clam up or they turn into a sort of motor mouth. Either way, the interviewer, if they're any good, they're going to understand and they're going to make allowances for that. So don't sort of sit there and sweat and think, oh no, I've said too much, I've made a mess of things. People, the person on the other side of the desk is human. They understand. They'll have had an interview for their job most likely, unless they're a startup. But anyway, they've had interviews themselves. They know what it's like. And interviews actually go two ways. And this is particularly the case when it's sort of a seller's market, if you like. If your skill set is in demand, as fortunately it is for programmers in many cases, you can sort of get a lot back about knowing more about the organization that you have applied to work for. Work out if the person who's interviewing you is going to be your manager. Well, try and work them out as well while you're sitting there. Do you like them? Do you think you can work for them? That sort of thing. It can go two ways. So that's that's a sort of soft side of things, soft skill side of things, as they say. Again, that's more like a life skill that I can't teach you in 2 hours because I'm not particularly good at it myself. But I am pretty good at C++. And what we can hopefully help you with is the technical side of the interview. And again, John corrected me. It's probably better to say a major goal of an interview is that you will be able to do the job you've applied for. You don't necessarily have to have the skills today, but you want to be able to show, I will be able to do this job. Hopefully in a reasonable time frame. You can show that you are adaptable and that you have the skill set to learn what you need to learn for this job. So you're sitting here because this is a C++ class. So for us, you want to be able to show that you're a good C++ programmer, right? Unfortunately, it's really, really hard to judge someone's programming ability in an hour or two. Really difficult. And you spend any time on sort of programming forums or Reddit or anything like that, Twitter, there are endless complaints by programmers about silly things they've been made to do in interviews. And there's really no good, hard and fast way of analyzing someone's skills in the limited time that you have available. If you come up with a foolproof, ironclad way, please let everybody know, because it's something the industry as a whole really struggles with. Yeah.
I just wanted to add that these days a lot of companies will have you do an online test first, so there's no interaction. So they will have you do basically something like all these hacker rank sites.
Yes.
Have you do the exercise just on your own.
Yep. Yeah. So if that didn't come out, they're saying a lot of companies will have a sort of pre-screen, online often test that you take before you even talk to a human. You apply for the job and you're sent back a URL and you have to answer some questions. Really is just a pre-screen, because if you put up an advert for looking for programmers, you might get 100 responses and 95 of them are really, really optimistic, let's put it that way. So it's just something people do as a sort of screen to avoid time wasters. So yeah, there are a few commonly used approaches. As I say, nobody's got the perfect formula yet. Sorry. Nobody's got the perfect formula yet, but there are a few commonly used approaches that we'll look at today of what you might be able to expect. And as I was saying, oftentimes programmers will really whinge that they're asked to do things in interviews that bear absolutely no relation to what they would need to do day to day, and they find this rather frustrating. And you have sort of horror stories of, you know, the guy who invented some particular library failed the Google screen for, you know, asking him questions about this library, even though he invented it. Things like that. You have these horror stories. And yes, doing things like inverting a binary tree on a whiteboard. And
He was the guy who wrote Homebrew, and he couldn't whiteboard invert a binary tree.
yes, not to name names too much, but Google are particularly notorious for their tough interview process. I think it's fair to say. The flip side of that is that if you've got Google on your CV, it's a very good thing. You're seen as an excellent person. But yes, but most of the time, as I said, the person on the other end, the other side of the desk, they're human. Most of the time they're not trying to help. They're not trying to catch you out. Most of the time they're trying to help you out. And you're not expected to know everything. And sometimes I'd need to look that up, is absolutely the right answer. Somebody says, well, how do you implement this algorithm? And you go, oh, well, I don't know off the top of my head. I would probably use a library. That can often be the right answer. I was asked in an interview once, how do you implement a fast Fourier transform? I was like, well, I wouldn't. I'd go and use a library because there are libraries that have superbly optimized FFTs. And they were like, well, yes, good. Okay, that's the right answer because we wouldn't want you to try and do it yourself badly because it's actually something that's quite hard to do optimally. And other people have gone away and done that. And it makes sense to reuse their code. So, yeah, people aren't trying to catch you out, and sometimes it's okay to admit you don't know something. So we were just talking about sort of pre-screen little online quizzes, questionnaires, exercises that some companies have, automated things. Some companies take this a little bit further, and something that's, I think, becoming increasingly common, although there's also been some pushback against it in some circles. But one thing that's really quite common is to have a take-home test. So this is something that's a bit bigger than just a little online questionnaire. This is something that you're expected to spend a few hours on. Maybe they'll give you it a week before your interview, and you're expected to submit it, submit your code, submit your solutions, for the interviewers to have a look at and quiz you on when you're actually sat there. So yeah, you'll be given a task to complete. And this may well take the form of a specification that you're being asked to implement. Write a program that does this and this and this. And they may well give you some skeleton code to get you started. Another form of it might be, here is some of our code. We want you to implement this new feature or add a new feature to it. And hopefully, the good ones anyway, they'll try and give you an estimated time for how long this should take to complete. Say 4 hours, 8 hours, 10 hours, 12 hours, whatever it is. And again, there's been some criticism of this approach to interviewing in that it sort of disadvantages people who don't have a lot of free time. If you've just got kids or you have to care for people or whatever it is, you might struggle to find 8 or 10 hours in a week to do the exam, to do the test. So There are criticisms of this, but I actually think it's still quite a good approach because it's actually relatively realistic. And because you're sitting at home and you're not there, with somebody you're wanting to impress looking over your shoulder as you're doing it, it takes a bit of the pressure off, and it's a more realistic environment. You can use whatever resources you like. So I actually quite like this as an approach. Could you ask questions like, how quickly can you get up to speed with an unfamiliar code base? This is in the case where they give you some of their code or some example code and say, please fix bugs, please implement something, please change this. It shows them to an extent how you approach problem solving, how you think. Of course, it lets them see your professional code, right? Do you write good quality, bug-free code? Do you write good code? And another really useful thing for interviewers is it gives them something to talk about in the interview.
Would they expect you to submit all your unit tests and all that sort of stuff with that code? This whole test thing, is it?
It varies. I mean, some places will not say that explicitly. Others, if you're very lucky, they'll give you some tests that fail and you're expected to make it work. But very often, no. It's done as something that's supposed to be realistic. So if you add new functionality, you're expected to write accompanying tests. So if you apply to one of these companies and they give you this take-home test, some pieces of advice, and Ollie, I believe your company does this, right? You give take-home tests, is that?
We do, yes.
You too. Well, so you can tell me whether I'm close to or way wide of the mark with this. But first piece, write tests. Write tests for your code. If you are tasked with implementing something, please write some code that does this. Write a test to prove that it does that, or to show that it does that. Right? Not only does it help, does it give you confidence that you've done the right thing, but senior developers love them, including that guy in the hat. Right? Document your code. Remember, you're trying to impress here. You want to show what your professional code looks like. You want to show what you would write if you were doing that job. So document your code. If you write a public function, put a doc string in there. Don't go over the top with comments. That can be a sort of code smell in itself. But documentation for your public functions, I think, would be a must. Another very important thing, follow the style of any existing code that you're given. Right? If they give you some example code and it uses camel case and a particular indentation style, or their class names follow a certain pattern, do that. Right? You might not like it. It might not be your preferred way of doing things. But once again, you're trying to show off here. So follow what they do. When in Rome, as they say. So follow the style of existing code. There is a great temptation of really wanting to show off, right? Because obviously you're trying to impress with this code. This isn't always a bad thing, but I would say don't try to be too clever. Yes, it can be quite impressive that somebody's written this huge template framework to solve the problem, but that's not always required. And very often what employers want to see is maintainable code, readable code. Don't forget, if you're working in an organization, realistically, you are probably not going to be the only person who's ever going to touch this code. So writing readable code, code that other people can look at and understand. That's, in my mind anyway, a bigger feather in your cap than writing something that is, ingenious, but you have to stare at it for 10 minutes to work out how it actually works. Yes?
Not levels. I would probably think they'd want you to know the standard library, so you know to use something that exists already, rather than try to implement something that's already in there.
Yeah, so if that didn't pick up, the employers, or you're saying that they will often like it if you use existing libraries rather than reinventing the wheel. And I'd say that's true, and this is, in fact, the next point. Don't be afraid to, use the resources. I've said Google the solution, but don't be afraid to use whatever resources you have at your disposal, whether that is using a third-party library to implement a tricky algorithm, whether that's going to Google or going to Stack Overflow. Don't be afraid to do it. It's what programmers do in the real world. It's what we do every day, is spend half the time on Google working out how on earth do you do something. Research is good. That's how we learn. Don't be afraid to do that. A couple of caveats. Obviously, don't just blindly copy and paste code, right? If you found something on GitHub, don't copy and paste it without attribution, because that's actually, stealing and license issues and all of that. If you've taken code from somewhere else, that's fine, but I would probably just include a link to the URL saying, I got this from here. Or if you found a Stack Overflow answer and you implement that yourself, that's fine, but just make sure you understand it. Because if the interviewer's got anything about them and has been looking at your code, they'd probably be able to recognize the bit that perhaps differs a little from the rest of the code that you've written. And they will ask you about it. They will say, how does this work?
One with the really short variable names.
Yeah, exactly.
And everything else is
Yeah. Well, on the variable names, actually, that goes back to the style thing. If they tend to use very short variable names, well, it's probably okay for you to do so. If their variable names have 20 characters because they're really explicit about exactly what it is, then follow that style. Finally, don't go significantly over the guideline time. If you're given a guideline time, and hopefully you are, it's okay. Obviously, they say 10 hours, but nobody's sitting over your shoulder with a stopwatch, right? And you take 12 or 13, that's fine. Don't go devoting your life to it and spending 60 hours to try and come up with something that's absolutely perfect. Because you're misleading employers who suddenly think you're an absolute genius because you've written this 50 million lines of code in 10 hours. And you're also, sort of, I guess, setting up the wrong expectations. You're misleading everybody. Another thing that sometimes happens is that they will give you a task that is impossible to do in the given time frame. Right? They give you something that's really, really, really difficult to do. Possibly as a final sort of stretch goal, extension goal. And the idea here is not to complete it. Well, you can if you can in the time, that's great. The goal is not to complete it, but just to make a good go of it, to see how far you can get in the time that you have available. And it also sort of weeds out people who have spent 60 hours on it as well. Oh yes, and write tests. Did I mention that? So yeah, take-home tests. Pretty common. Has anybody been given one of these to do?
Oh, yeah.
Yeah?
Yeah, it's pretty standard, like, in front-end development.
Yeah?
Yeah.
Anything you would add to those do's and don'ts then, if you've...
Well, sometimes I'd say don't write tests when there already are tests, maybe. Sometimes what you're given has the tests.
Yes. Yes, yeah. If they give you tests, well, that's brilliant, because you don't have to do it yourself.
What you have to do is just make sure you run the test and your code passes their test
Yes.
before you submit it.
Yeah, yeah. If you're given tests, make sure your code passes their tests. That's solid advice.
Yeah, I mean,
Okay. Excellent. Okay, so you've applied for this job, you've passed the initial screen, they've given you this test, you've sent it back. It's Wednesday afternoon, you've got to come in for your interview, you're all dressed up, you're nervous. They sit you down, you have that general chit-chat. They say, right, just got a little couple of exercises we'd like you to do.
So before you go on to that,
Yeah.
what about portfolio on your? Will you ever say if you have stuff on GitHub that you've done to people?
So my experience with this is that a portfolio or a sort of library of code you've written, or a body of code that you've written on GitHub or something, is a really, really great thing for showing off what you can do, for showing off the kinds of things that you're interested in many cases. Yeah, it's great, and it's what will lead to the interview often, I think. So it will be, you'll be looking at the CV and they'll be, they wrote this library, and perhaps someone might even go and look at it online and go, hey, this person's pretty good. We better get them in. It also gives you something to talk about in the interview, which can be very useful. It gives you a chance to sell yourself. It gives you a chance to advertise what you can do. And it gives the employer or potential employer, gives the interviewer something to talk about as well. And if they're being very nice, it lets them give you an opening. They'll say, I looked at your GitHub and I saw you got this. Tell us about it. And if that happens, your eyes should light up, because that's your golden opportunity to really, stress how great you are and why they should hire you.
I can confirm that it helps to give you something to talk about where you don't necessarily get the job. That's happened to me.
Oh, no, of course, it's no guarantee that you're going to get the job. You still have to perform well in the interview, but it helps you get to the interview in the first place.
It's a conversation that you can have, like, it's a starter.
Conversation starter, yeah. Yeah.
In the interview.
Yeah, very definitely.
One thing I've noticed, I think, from speaking to some of the more experienced developers in my team, they've mentioned one of the negative things they come across is sometimes some companies have some problems that they need to solve and they don't necessarily want to pay. You come in and they give you like a brief information about it and ask you questions, and then you sort of answer those questions to solve that problem they've got, and then you never hear from them again.
Wow, that is, I must confess, I hadn't heard of that. That sounds very underhanded. So that probably didn't come out on the microphone. But saying that perhaps with these take-home things as well, the company has a legitimate problem, a legitimate new piece of functionality they want, but they don't want to pay anyone to do it. So they set it as an interview problem. Someone solves it, and then they're never heard from again. So you're getting free labor for a few hours, which it sounds, borderline illegal, really, if you ask me. But no, I hadn't come across that. If that happens in real life, that's really not great.
From speaking to a few people, they've mentioned, I think one of them was giving me advice and saying there's some questions that you get asked and sort of you should kind of think about it properly and sort of don't give everything that you got.
So don't.
Sort of,
If you feel like they're fishing for your expertise for free, then perhaps be a bit more cagey in answering.
but you need to be able to sort of understand when somebody's doing that.
Yes.
You tell, because sometimes, because you're so desperate, eager rather to get the job, you sort of give everything, so that sometimes it does pay to be a little bit more reserved rather than sort of have like a bit of a verbal diarrhea and everything out there.
So if I guess what you're saying is if you get the sense that the interviewer is sort of taking you for a ride and trying to get something for nothing, then be aware of it. And it comes back to the thing about the interviews really go two ways as well. So yeah, that really does sound quite awful. Yeah. So also, we're talking about programming exercises. We almost were talking about programming exercises. So yeah, this is something that is almost universal in interviews is that you will be given some sort of problem, some sort of exercise, something to do, something to implement, something to write. And you will be, unfortunately, usually have someone looking over your shoulder or looking at you from the other side of the table, watching you do this. And it's not very nice. But the goal, what they're trying to do, really, again, it's not usually not to catch you out. The goal is to try and work out how you think, work out how you approach a problem, work out, do I like the way this person thinks? So not just testing whether you have memorized how to reverse a binary tree, or how to, traverse a linked list or whatever it might be. They want to kind of get into your head a little bit more. If you're lucky, and hopefully most places do that these days, they'll give you a real editor, a real IDE, and it'll just be someone who will be almost like a pair programming thing. Sometimes it's just pen and paper, or even the dreaded Google Whiteboard, where which makes things a lot harder. I don't know why it is. It's a lot easier to write code on a keyboard in an editor, even if you're not getting underlined squiggles and all of those things. For some reason, it's a lot easier to write code on a computer than it is to write it on a whiteboard or on a piece of paper. Answers on a postcard as to why, but yes. If it's pen and paper on the whiteboard, that's unfortunately just the way it is. When you have one of these, you can expect plenty of follow-up questions, or even not even follow-ups, even while you're doing it. Why have you done it this way? What problems might there be with this? What about this corner case you haven't covered? What are the limitations of your implementation? Might even be sort of slightly more technical questions like, okay, what's the complexity? What's the big O complexity of your implementation? That sort of thing. So again, who's had to sit there and do some of these things, whether it's on a computer or on a whiteboard or whatever? Yeah? Yeah. All right. Yes?
The term corner cases versus edge, what's the difference?
Nothing really. Corner cases, edge cases, sort of awkward, if we're talking about functions, for example, awkward inputs that don't behave like...
One corner is just meant to mean even more...
Yeah. So you've got an edge, and then the edge of the edge is the corner, right? Yeah.
Very unlikely, as opposed to just unlikely.
Yeah, so I don't know, if you have a function that takes floats or doubles, does it handle nans, does it handle infinities, things like that?
What do you discuss about these particular cases? When you come up with the algorithm, or when you test and then you realize that maybe you forgot something?
So my advice here, well, I'll get to it in a second actually, but let's just start off with the general advice for these programming exercises is that there is no real substitute for practice. Practice, practice, practice. There are lots of good websites, HackerRank and my mind's gone blank, but there are lots of these websites with little exercises on that you can practice. Code Wars, Leak Code, Geeks for Geeks. Yeah, as I say, there are lots and lots and lots of these websites. People have just thrown up half a dozen that I hadn't heard of, which is awesome. There are lots of these websites that have, things ranging from the very simple one-liners to things that you have to really think about, are really tricky algorithms to write. And there's really no substitute for practice. The more of these you do, the better you will get at them. So practice, practice, practice. Second piece of advice, ask questions. So this comes back to what Laurent was saying about corner cases. I would say a good approach would be, first of all, write the obvious, if there is an obvious solution, And then if you yourself say, you know, this works, but it doesn't handle this case, is that a problem? That shows really good understanding of the problem. That would be a, you know, a big tick. If you yourself can recognize, okay, this is a good general solution, but it doesn't handle these problematic cases, you can turn around to the interviewer and say, you know, is this okay? Would I have to handle these particular awkward inputs? That would be.
Is that only a matter of runtime, of improving the runtime from the initial version to moving to something new? It's also something which cater for all cases.
Yeah. I mean, really what you're trying to show with these things is how you go about problem solving. So a really good approach to it is to start with something simple. Start with maybe it's order n squared, you know, not ideal, but it works. And then, you know, you can turn around to the other person and say, okay, well, this works, but, and if you can get there before them, that shows really good understanding.
Some people say that going through from the naive solution and then optimizing that, like, is a good way of showing how you work.
Yes. Yeah. So going through from the naive approach to the, you know, to the.
Numbers, you can start off with just like this, you know, laboring this expensive call that's always checking every single number, and then you add in the sieve.
Yep.
You made it better, and so that shows like how you can optimize.
Absolutely, yes, Tom.
Question from the internet. What if someone asks you to write code that prints the source codes of the file you're compiling?
Code that prints the source code of the file that's being compiled. Such a program has a name. Such a program is called a quine, Q-U-I-N-E. And no, I would say that's not a good question. That's asking you to do a magic trick, basically. That is absolutely unrelated to anything that, you know, would be done in the real world. It's not to say it doesn't happen. I'm sure it does, but it's, yeah, I wouldn't like that as an interview question. I wouldn't ask that. But you know, perhaps it's one of those things where they want to show, they want you to start thinking about it. They want you to think, well, how would I do that?
There are programming languages where they have a built-in feature where you can do this, and in that particular language, maybe they're asking you because they want to see how well you know the feature set, but in C++, no, it's daft, really.
Yeah.
Isn't a classic one asking for a user input? Please input a number from 0 to 9. And then obviously the easy one is just get the number in, but you don't do any checking. And then you start going through what it puts in an A or something like that, and then you go through and check.
Yeah, that might be a good exercise to go for. So a good you know, sequence to go through is, well, okay, write a program that accepts a number from the user, perhaps prints out all the factors of that number. Say, how would you do that? And yeah, so you start off just with a basic. In C++, you might do sort of cin, and then you go through and you make sure the numbers. You add a line, or make sure the number's in bounds, otherwise you ask the user again. And it's almost like doing one of these TDD exercises that Ollie goes through, of just, you start off with something that works and you refine it.
I mean, you can always go throwing a cat with that sort of stuff.
You could, might not be the best way of doing it, but it would be one potential way. If you did that, expect some questions from the interviewer of why have you chosen to use a try and a catch here. But also, don't just ask questions. Talk through what you're doing. Explain what you're doing. This is not, hopefully not just you sitting in an exam and they're sitting there with a clipboard marking you down. As I say, the goal of these things is to work out how you think. So if you can do it like a pair programming exercise where you talk through, okay, now I'm going to add this, and now I'm going to do this, and then, oh, well, that doesn't handle the case where, you know, I is equal to 0, so I'll just add a line of code for that. That's a big, that's good. right? That's yeah.
I do remember one thing that's almost the opposite of this, where I was given actually a page with a program, and the idea was, okay, look at this for half an hour, we'll be back. So you'd sit here and mark everything you think is kind of iffy or doesn't quite work.
We'll actually talk about exactly that just after this. Yeah. So yeah, ask questions, talk through what you're doing, iterate on your solution. But having said that, don't always just dive in head first. It can often be a good idea, if for nothing else than your own sort of sanity, just to write a few, iterations of whatever algorithm, say, with a pen and paper. Just make sure you know or have an idea of what the first iteration will look like, rather than just sitting there staring at a blank screen, your mind going, where do I start? Hopefully they've given you a pen and paper. If not, ask. Just write a few notes, sketch. Okay, so we'll begin 1, and then 1, 2, and then 1, 1, 2, and then 1, 1, 2, 3, 5, 8, whatever. I can't remember the sequence off the top of my head.
One of the first things I do when I'm doing a massively complicated kata that's actually got an input multiple arguments is just to see out the arguments, especially if they're nested vectors and things. Just to pick it off, just to see what I'm actually
Print out the input and
the input just to see
make sure you're getting what you think you're getting.
Exactly.
Yeah. And once you've done all that, practice some more, because there's really no substitute for being good at these little exercises. Really does help.
What about if you have to do the whiteboard? If you have to make some correction, you need to allow for that by leaving some blank space if you want to add some.
Laying out code on a whiteboard. Yeah, well, if you know that in a minute I'm going to add, if I equals 0, return 0. If you know you're going to have to do that in a minute, then yeah, leave some space and sort of mutter under your breath. Okay, well, just going to put something in there in a minute. And
That you might.
most people be happy with pseudocode. It's like syntax.
yeah, absolutely. I mean, if you're writing on a whiteboard, no one's going to expect it to perfectly compile, and you'll certainly be excused for forgetting the odd semicolon here and there. The idea, especially with the whiteboard tests, the idea really is to see how you think on your feet. And companies that do that those are the ones that will tend to try and put you under more pressure in an interview and try and really, really think about how you. How quickly you can adapt and think. And then they'll do things, well, if you go through it really easily, they'll go and add a twist. Say, well, what about if you needed this? And how would you modify your solution? So people have anything else to add to this? Yeah.
One point is like getting familiarized with the programming techniques that are standard established techniques like brute force, dynamic programming. So in this practice, we need to get familiar with those approaches.
Get familiar with programming techniques, approaches, patterns.
Whiteboard programming is all about showing that you know design patterns.
So guys, whiteboard programming is all about showing you know design patterns. Yeah.
Check whether you can use Google. And don't be shy to use Google.
Yeah, well, I mean, it depends on the environment you're given. They'll probably set out the rules quite clearly as when you begin. So, and then you can say, I just have to look this up. And they'll say, oh, that's fine, of course you can. Or they might say, no, just try and do it the best you can.
A driver to drive from France, north of France to north of Russia without any map.
Asking a driver to drive across Europe without a map. It's more like expecting a driver to drive without having to use the highway code. And if you ask a driver, well, what's the stopping distance at 50 miles an hour in the rain, it's probably all right for them to go, oh, I don't know, I'd have to look that up. But then when you're actually doing it, you want them to keep a safe distance from the car in front. It's not a very good analogy, but
depending on what type of work you're being employed to do. If they want to employ you on a contract basis and you're just doing quite simple code, and they want to produce the code very quickly, then they want someone who doesn't need to spend a long time looking it up in Google. They just want to
yes.
get it done and get it compiled, get it out.
Yeah, so obviously well documented, so that when you leave.
Yeah, but it depends. Otherwise, if you're more of a researcher, or it takes longer to do, doesn't it? If you don't know, if you've got to keep looking it up.
Obviously, you check.
Yes,
Contract work, you probably expect to just crash stuff out.
yeah, so I mean, it goes both ways. On the one hand, it can show that you're sort of, able to go out there and reuse existing code rather than reinventing the wheel. The flip side is that perhaps it's a wheel you should already know how to implement. So yeah, it can go both ways. Okay, so the third thing that commonly gets done in interviews, as was touched on earlier, is fixing bad code. So this is something that I also actually think is quite a good way of testing people's knowledge and ability. They'll show you some badly written code and ask you either to fix it or to look at the code, maybe a printout, maybe it's on the screen. Often, as you say, they'll let you study it for a while, make notes, and ask you, what are the problems with this code? If you're lucky, this will be sort of outright broken. Yeah, they might even give you a compiler, by the way, so that you can test your fixes. Or they might just give you a piece of paper and ask you to do it by hand. If you're lucky, the code is sort of outright broken and there's something really obvious. A more sort of tricky but more realistic way to do it is code that looks right, looks okay when you first glance at it, but which contains bugs. So as I say, I think this is actually a pretty decent way of doing things. And the idea here, why this is done, the idea is to show how well you know the programming language that you're going to be asked to use. Whether you know the common pitfalls of that language, whether you can spot problems in existing code, or whether you're likely to avoid these problems when you write your own code. Hopefully they don't do this horrible thing of giving you some of their real production code, which has a bug, and asking you to fix it. That would be a bit mean. But yes, this is meant more as how well do you know this programming language? How well do you know the pitfalls? How well can you avoid falling into the traps? And C++, well, there's no getting around it. C++ is a language that has many traps. There are many things you have to be aware of. So the best advice I can give you for this is to practice writing code. And I know that was the same advice as the last one. But I mean this in a slightly different way. Because for that I meant practice exercises, get to know implementing algorithms, get to know how to approach problem solving. For the last one, it doesn't really matter what language you use, because a solution in C++ will probably look very similar to a solution in Java or in Python or whatever. But for this is all about the language. And in particular, if you can write bigger bodies of code, so not just a 10-line algorithm implementation that you might do for the code katas, but an actual proper project of a few hundred, a few thousand lines, you're going to inevitably run into some of C++'s traps. And you're going to get used to recognizing them and get used to avoiding them to the point where it will just become absolutely automatic. And that's where you want to get, and that's what an employer is looking for. Can you spot these things in order to, avoid writing them yourself, in order to, if you come across some code in their repository that has these problems, you know how to go and fix them. This is more, I would say, this gets asked of junior developers less often because they are sort of, how can I put it? They're excused a bit more from writing buggy code, right? Because if you're starting out, you're not expected to be an expert yet. But particularly if you're looking for a more senior role, this is something that gets done often, because if you're in a more senior role, your code will often your role will often include doing code reviews. So they want to see whether they're any good at code reviews, see whether they're any good at spotting problems. So if you're given something like this to do, particularly in C++, look out for all the usual suspects, by which I mean memory leaks. If they're not using smart pointers, that's like a warning sign right away. Usually get memory leaks. Out-of-bounds array access is another really common one. Unchecked inputs to a function that then accesses array, that sort of thing. Uninitialized variables is a really common one, just sneak them in there. Also being aware of uninitialized member variables, make sure every member variable gets a value in every constructor. Use after free, this is another thing that comes up when you're doing manual memory management, which still a lot of people will test on, mostly because it's an area that's so rife with these problems that it's quite easy to write a piece of code that has lots of problems, even though in the real world...
You've deallocated it, but then you're still trying to access it.
Exactly that, yeah. Dangling pointers, dangling references, dangling iterators. These are things that can all manifest themselves in C++. If you're returning a reference from a function, that's something, for example, that should set off alarm bells, and you really want to look at it carefully and make sure it's working. Slicing, maybe less common, but it's still a bug that is quite easy to hide in some code if you've got an interviewer who's feeling nasty. So slicing is where you have a function that takes a base class by value and you pass it an instance of a derived class. Well, all the derived information gets, as they say, sliced away, and this is a bad thing. The other common thing is copy constructors, copy assignment operators, destructors, all these uctors that don't work properly, don't quite do the right thing. Watch out for those. That's another something that's easy to get wrong. So people love putting it in tests because, as I say, writing bad code is actually, writing code for somebody else to spot errors in is not the easiest thing in the world. So people will often tend to go for these usual suspects because they're the really easy ones to write test code. If you're at a bit of a higher level, you might get something involving lots of threads, and you have to worry about deadlocks and things like that. That is actually quite nasty, but yes, that's another thing that comes up.
What about if the code includes the old smart pointer, auto PTR?
If the code includes auto PTR, ask them why it includes auto PTR. Is it okay to replace it with unique pointer? If they say, of course, then that's a big thumbs up, because it means that what they wanted you to do was to recognize that auto pointer is bad and unique pointer is good. If they say, no, we're not using C++ 11 yet, probably just walk out, because it's not something you want to work for. Honestly, you don't want to work for a company that's still using C++ 98. So the other sort of quite tricky thing that people will do is they'll give you a piece of code that actually looks fine at first glance, at a quick glance. So the thing to do with that is just think about, corner cases, awkward inputs to functions. If it's floating point, does it handle nans? Does it handle infinity? Does it divide by, if it's integer code, does it divide by 0? Does it, oh yeah, another one I should have put on the usual suspects. Integer overflow, it's another very common one. Things like that. So has anybody had to do, well, yes, you said you've had to do one of these. Has anybody else had to do this sort of fixing bad code idea? No? Ah. Do you have any more advice that you could?
It's been a long, long time. I barely remember what to do, but it was stuff like this.
Okay, yeah. Okay, so that was part one. It's all right, don't worry. That was part one of today's lesson. I've taken up half the time, so that worked out pretty well. So part two is a bit more practical. I said there are three common approaches. Well, I can't really give you a take-home test. Well, I suppose we could, if people wanted to, but I can't really do that today. The bad code thing, well, again, it's something we could try if you wanted to. It's something I put in the tests sometimes, the end of module exams. So people who've done those will have had a little bit of practice. But for the most part, I thought we'd have a go at the second item, a few practice exercises to try and see how you solve problems. So we've got just a couple of them to occupy the next 50 minutes. So hopefully most of you, all of you, almost everybody has a laptop in front of them. But this, you can use whatever you like. IDEs, textbooks, Stack Overflow, Google, whatever you like, any resources, that's fine with me. Ollie and I, well, he doesn't know it yet, but he will. We will wander around and we'll try and sit with everybody and we'll try and ask some pertinent questions about why you're doing things the way you're doing them. Thank you. And then I'm going to ask for a volunteer to come up, and we don't have a whiteboard, unfortunately. So we're going to have to work out how to do this. But I'll ask somebody to come up and present their solution and talk through it. And then I might ask some questions, Ollie might ask some questions. I'll encourage the rest of you to ask some questions of each other as well. Awkward, nasty questions. Not awkward and nasty questions. But the idea is to kind of put people, make people think on their feet, right? Try and simulate the interview environment as best we can in a big group of sort of 20 of you and one of me. I will say nothing is a trick question. Right, the solution's only a few lines long, 10 lines long at most. So don't go racking your brains too much. Well, no, please do, but realize that if you've written 200 lines of code, you might be barking up the wrong tree. Sorry?
That section whiteboard, people have to say it.
Say it.
Yeah.
Yes, sign your code. Sign language, please. No. Okay. So everybody, looking at me with bated breath now. I didn't mean to make everyone nervous. No, relax, enjoy it. The first one, here we go. I want you to write a function called sumInts. Unfortunately, it's right at the break of the screen, but I'm sure everyone can read that. SumInts takes a vector of ints. I want you to return the sum. Does that sound plausible? Yeah. Yep. All right. I'll give you maybe 5 or 10 minutes to do that, and I'll come around and have a chat with everybody. Of course. Okay, so most people here have had a go at that, and Scott here has very kindly been volunteered to go through his solution. Our first thing is, does it work? And it absolutely does work. So, yes, okay, but maybe you want to tell us about your solution. How did you come up with it? What's it doing?
Yeah, sure. So the put back together a few ints. First of all, got an int for total 0, then use a for each loop that iterates through it, and then just sums them up, and then returns the total. So it should return 10.
Why did you decide to use iterator?
Just an arbitrary choice, really. I could have used a for loop, I guess, but just like the stuff to go with. Yeah. Guess so.
Well, that is a for loop.
Oh, I mean like the full. What's the other one? Yeah.
Yeah.
Or you could have kept it like that and used auto.
Yeah, so that's would be probably the next question is, can you think of any obvious ways to improve this code to make it, because there's nothing wrong with it in the sense that it works, but it's not necessarily using all the latest C++ ways of doing things. This would be the correct solution in C++ 98.
I actually, I know what you mean about the auto instead of the standard vector in constant iteration.
You just replace the type with auto.
Yeah, but I actually, when I'm doing a bit longer code, I actually quite like to see not have the auto there, because then you can keep track of the time.
So if it's not obvious, say you're making a function call, that's arguably fair enough. If it's something like vec.begin, when you know it's an iterator,
Yeah.
you know.
But it's, yeah, I think it's referenced it, but
I'd say it's not so much preference. Well, there is some truth to being preference, but if it's obvious what the type is from the right-hand side, you should probably just use auto. In this case, it is obvious.
Do you use const also to get automatically the const iterator?
One more.
what's the const iterator?
Compatible type, you could have also used vec. Actually, yeah, so using auto here would strictly be the same. You want to use vec.cbegin and cend to make it truly.
No, because vec is const. And dot begin at, yeah.
Yes, it makes a difference.
Yeah.
So what's the difference between const iterator and iterator?
Okay.
Vec is const. It doesn't return an iterator, it returns a const iterator.
Yeah, so that's correct. The difference between iterator and const iterator is that an iterator allows you to mutate the values via that iterator, and a const iterator doesn't. So in this case, well, firstly, we don't want to mutate the values, we just want to read them, so a const iterator would be the correct thing in any case. And the second thing is, because our vec was given to us as a const value, we can only use a const iterator. We can't have a mutating iterator to a const vector. That won't work.
So if you just had iterator in there, it would throw a...
Which is exactly what Scott did in the first place.
Okay.
But yes, so one improvement we could make to this would be to use the auto keyword in there. Which cuts down on the typing a bit. Yes?
When you're in discussions like, should I use, for example, cbegin or begin, and you say, well, I mean, in that case, it doesn't make a difference. Can you, does the argument work when you say, yeah, but it is more explicit in the sense, even if it doesn't make a difference?
The argument is that, so it's about vec.begin versus vec.cbegin. I pointed out that actually in this case it makes no difference. And Michael's saying that, well, it might make no difference, but it lets you be more explicit, saying I definitely do want a const iterator. And yes, I accept that argument. So let's change this to be cbegin and cend. So this is now our second iteration of the code.
Could use the
If you're
Use range variables.
Actually, we could use string begin, then open bracket back.
we could use standard begin brackets
Case regular.
vec, or even standard C begin brackets vec. There is another improvement. So, okay, we're going to flip the interview thing round on its head now, and I've shown you this code, and I'm saying to you how this is some of our old legacy code here, perhaps even when it still said const iterator. How would you make it better? How would you update this?
You just have auto I colon vec.
Yes, so the way to do, good way to do this would be to use a range-based for loop. So John's going to talk me through it. So I say auto I,
So auto I colon the vector, which is exactly the same thing as
Yep.
you've just written, but it's just identity.
and then
Obviously here you have to get rid of the star and it's just an I then, because that is the iterator for the vector.
yep. So now this is the new range-based for loop that was C++11, so we don't have to do that const iterator thing. We don't even have to do the 3-element for loop. It does it all for us. This uses, the begin and end all magically. So this is exactly equivalent to what we had before. It's just nicer to look at, easier to see what's going on.
Another version. Full version, extra improvement.
Tom has an improvement.
That will make extra versions, like from version 2 to version 3 of the program. We'll add the comments, what the thing does, so the next person knows without actually. I mean, this is very basic, but assuming it's very complex, I think the code will help the next person to understand what we meant by the code.
Adding comments.
Yeah.
You would add a comment here.
If you can't understand what this is doing.
No, I mean, I said this is trivial.
So,
in a general, yeah.
Michael,
it's a very
something more
complex
serious.
code.
I'm not the authority on this, but I've heard it can actually be counterproductive if you overuse comments.
Yes.
Comments rot.
Yeah. So,
Like a long comment, but it's like, this is determining the total sum of I. In this case, it's a very basic,
So-
so you don't have to. But assuming we are working on the real life code, and you did something, you spent a week, and you say, this does a magic.
so
Sorry if I interrupt you.
No, go on.
You have, I mean, a lot of libraries, they use this kind of box rules. And even if it's a simple function where from the function body itself becomes immediately clear what it does, it would make sense, to add, for example, a function docstring.
Yep.
With the signature and maybe one or two examples of how it's used.
yeah. So in terms of comments, two things to say. Firstly, adding function documentation is never a bad thing. I mean, even for something as relatively simple as some ints, because at some point we might generate the documentation. It's nice to just have everything documented, even if it is relatively simple like this, and the doc string is just sums every element of vec and returns. Yeah. The other thing on, sorry, go on.
Will you need to discuss whether the case where total overflows the rank?
Yes, we do. We'll talk about that in just a minute. And the other thing to say about comments is that, yes, comments are good, but too many comments are bad. And a good rule of thumb, or not rule of thumb, a good guideline that I heard was comments should say, if you're going to comment something, you should say why the code is doing what it's doing, not what the code is doing. Because if you put in a comment that says what the code is doing, and then someone else goes and changes that code, and they don't change the comment, that's actually worse than having no comment at all. A misleading comment is worse than no comment at all. So a good guideline is if you're commenting, explain why you're doing it. Perhaps it's something that the next reader of the code will sort of scratch their head and go, well, this is a bit weird. Why is that? That's a good place for a comment. Putting a comment above the for loop saying iterate through the vector is not helping anybody, because anybody who is well versed in C++ is already going to be able, or any other similar language is already going to be able to see that we're iterating through the vector.
The one that's a bit of an aside, the one thing I have using that auto I is it gets messy if you need an index. Do you just put in a index equal naught and then index plus plus and then use that in the code? I know it's not relevant to this.
So about indexing, yes, one of the drawbacks of a range for loop is that it doesn't do indexing for you. I would say if you need indexing right now, use an old-fashioned three-element for loop, you know, int I equals 0, I less than vec.size. That would be my advice at the moment. When we get ranges in C++20, that will change, but at the moment, that's the best way to do it. Okay, so this is 1, 2, 3, 4, 5 lines now. We can reduce this. We can make this a bit simpler. And I saw a few people did this as I was walking around. How else could I do this? That's not 5 lines, but 1. A numeric algorithm called accumulate. Yeah, several people. Well done. So most standard library algorithms live in the header algorithm. Accumulate, for obscure reasons, lives in the header called numeric. But now, we can just do this. So from the beginning of the vector, we accumulate, that is, sum up everything from the beginning of the vector to the end of the vector, and we begin our accumulation with the value 0. And hey, if we really wanted to.
Just to be clear, if you were to start with 10, for example, then it's going to
Yep.
be 10.
Yes. Yeah. So yes, if 0 there was 10, then we'd have 10 plus 1 plus 2 plus 3 plus 4, which would be 20. So
What is the value in let's say they are unsigned numbers, so like minus 50, minus 20, and so on. Would that give us then the correct value as well?
If they're all negative numbers, it's going to add those negative numbers exactly as the way you would expect negative numbers to be added. So if it's minus 1, minus 2, minus 3, minus 4, you're going to get minus 10. Okay. So if you were to go for this solution instead, you would get marks from me. It shows good awareness of the algorithms that are in the standard library, of how you can use the standard library to make your code easier, more readable, because now we don't even really need this sum-int functions at all, do we? We can just, just use it, accumulate in the original place.
It looks more functional.
It looks more functional. Yeah, as in functional programming.
Yeah.
Yes, absolutely. Yes.
Well, I mean, it does make sense if you want to expose it, for example, for somebody else to use, because now you don't have to work with iterators anymore, and you basically, it basically does what you would expect if you have a function that's named sum vector.
Yes. So I said you don't necessarily need the sum-int function anymore, but there are cases where you might want it, yes. So this works. It's going to give us the right answer. It's 1 line of code. We're reusing existing facilities. This is great. Is it? Is it? Can anybody think of any problems there might be with this? And Lauren's already mentioned it, actually, but for anybody else? What if I gave you a vector with some huge numbers in there? A vector of 2 billion and 2 billion and 2 billion. Overflow. Well, you're going to get, yes. What's going to happen is you're going to get integer overflow, which is undefined behavior as far as the C++ standard is concerned, and undefined behavior are the big scary words that we try and avoid. So yes, this is absolutely going to work, provided the sum total fits into an int. Because otherwise, the moment we exceed the capacity of an int, we're going to be in trouble. We're going to hit this nasty undefined behavior, and all bets are off, and absolutely anything could happen. So, can anybody think of a way that we might be able to not avoid but mitigate this, make this less scary? Long.
Well, you could test whether, before you return the result, you could test whether it's actually within the numeric limits of the top of all of them.
Unfortunately, at the point at which you so the thing is, before you return, you could test to make sure the answer is within numeric limits. Unfortunately, by then it's too late, because the moment you've done the addition, the overflowing addition, that's the point at which you've hit undefined behavior. So, if you want, sorry.
Test the first numbers going in, and then convert to strings, put them together, and then
Use strings. So what you're effectively saying is use some sort of arbitrary sized integer library, which Python's got big ints, and there's a boost library that does it. And yes, that would be an absolutely ironclad situation. Unfortunately, arbitrary sized integers do get quite expensive. So expensive to use, as in slow in performance. But Tom mentioned the magic words, which are long. So C++ has a variety of integer types. And one thing we can do is we can change this accumulation just by doing that. So now, our initial value is still a 0, but it's a 0 of type long int. Oh, I am still returning an int. Well, we'll get to the return type of the function in a second. So, what's the size of a long? Yeah.
Is it double a double or something like that?
So the size of a long, unfortunately, the only answer you can give is at least as big as an int, right? And in fact, if you use Windows, then a long is in fact exactly the same size as an int. If you use Linux, then on 32-bit, long is the same size as an int, and on 64-bit, it's twice the size of an int. So long isn't the solution we're looking for in this case. In this case, we want something even bigger. We want long, which I'm not kidding, is what it's called. And this, on all platforms, is going to be big enough. The other thing you could do if you wanted to be absolutely pedantic.
Frankly, I mean, it just moves the problem further away from you to solve.
Yeah. So if you wanted to guarantee that you were using a 64-bit integer, you could change your summation to happen over. You could use this standard library type int6040, which is going to be an alias to long most probably.
Quick point there, you would need to include, should include c int to true.
Yes, you probably have to add the head. Although you're almost certainly going to get it from one of those other headers you've included, but whatever. But Michael's saying, yes, this is going to work. This is good. This is going to give me a lot of extra freedom. But you're sort of just moving this along a bit. You're just moving the problem along. Eventually, if I had a big enough vector with everything that was int max, I'm eventually going to hit the problem again. Yes, that's true. But you have moved the problem a long way away. No, pun not intended in that case. Right?
One, since we're casting from a large type to
Sorry, imagine I changed the return type to match as well. Sorry, that was... I could. Or can I? Can I? Can I do this? Is this going to work?
Yeah.
Who votes yes?
You need to yes, and you need to put on the line 5 as well.
I need to change the prototype as well, yes. So yeah, I could do that, or I could,
Compiler will work out this anyway.
can't type. So I could do something like that. You happy? Good. So yes, this sort of shifts the problem along. To shift the problem, to solve the problem completely, you would have to use some sort of arbitrary sized integer library. The other thing, or not the other thing, another thing you could do, which would not give you the correct answer but would avoid undefined behavior, is to actually do the summation in the unsigned domain and convert the result back to signed in the end. Now that wouldn't give you the right answer, but it would avoid undefined behavior because overflow for unsigned integers is well defined. It just wraps around. So that avoids undefined behavior, which is good, but still wouldn't necessarily give you the right answer, whereas this is going to give you the right answer for all sort of practical inputs anyway. And we've now reached 5 to 9, and I still had more problems I wanted to give you. I mean, this was just the beginning. All right, how about we just have a little look at the next one and a little discussion about it rather than
Do we need to quote the complexity or explain the solution?
do you need to quote the complexity?
Yeah. At the step you say.
Oh, well, I would say if you are asked what the complexity is, you should be able to have an answer or be able to reason about an answer. So, what is the algorithmic complexity of accumulate? Since you brought it up. Yep. So we have to touch every element on the way through in order to, get their values. So accumulate is linear in the size of the vector. Right, so
If somebody came up with a solution creating a new structure to calculate like a partial sum and create a new vector, you would say no.
Partial sum.
Yeah, there are ways of doing this that are really complicated. Yeah, I mean, I suppose the incredibly functional way of doing this would be to just drop the first element off the vector, and then call some ints of a smaller vector and do recursion that way. Tail recursion, yeah, which not all compilers do. And anyway, that wouldn't be a good way of doing it in C++.
Just to mention the most modern way in C++ 17, you could use std reduce, which supports parallel execution, and then it can be really fast because it will break it up into chunks for you.
Yeah. So there's another function called standard reduce, which is like standard accumulate, except that it does things out of order, which doesn't matter for ints, and also allow, not that any implementations have it yet as far as I know, but in principle lets you run this in parallel, which is nice. Okay, this was the second exercise I was going to give you because I thought the first one that was going to warm you up, and this was going to stretch things a bit, right? Rule is anagram. So we've got two strings, and we return true if one is an anagram of another. Not an anagram is, right? The same letters, but in a different order. Or not necessarily a different order. The word is an anagram of itself. So I'm not necessarily asking you to do this now because we've got a minute left. But can anybody just off the top of their head, is anything yelling out to them?
Yeah.
How do I do this? How, what's the solution to this?
They've got one's got to be.
First and last compare. If the indexes.
So I'm not asking if one is the reverse of the other. I'm asking if it has the same letters but in a different order.
Find for each letter, and if it
Sort
breaks,
and compare.
then it's not an anagram.
Find for each letter, and if it breaks, then it's not an anagram.
Sort and compare.
And then you have to make a copy.
Yeah.
All right. So somebody, a couple of people I think, said the right, well, not the right answer, said a good answer, which is that you sort both strings, and once you've sorted them, if they're the same, then they must be anagrams. That's a perfectly valid approach. Now, in this case, I've deliberately, because I'm mean, given you const reference to strings. So if you were going to use this sorting approach, you'd have to first take a copy of each string. So, anybody think of a way of doing it that doesn't involve a copy? Sorry? Counting.
You know that you're not having a wide strings here, so you have to do 256.
Yeah, that's that. All right, so you'd have a frequency table, and you'd count the occurrences of each letter, and if those frequencies are the same, I like that approach, actually.
No, you subtract. You can't string one.
Oh, and then subtract them the other way around, and if your table ends up all zeros. Yeah, no, I like that. That's constant storage, linear time in each. Yeah, no, that's great. No, well done. Didn't even occur to me that. Well done. So I like the standard library, and that. Come on, yep. There is, of course, they've done it for us. There's a library called there's a function called isPermutation, because if one string is an anagram of the other, then it's a permutation of the letters. That's what an anagram means. So we can just return isPermutation, one or the other. Now, had we had a bit more time, I was hoping someone would come up with this. I was going to ask him a nasty question, which is, what is the algorithmic complexity of standard permutation? It's not n factorial. It's not great, but it's not that bad. It's actually n squared, I believe. So, is this better or worse than copying the strings and sorting them and comparing the sorted strings? The answer is, I don't know. It depends on quite a few things, because if we're using dictionary words, well, most dictionary words are quite small. So the n squared isn't a big deal. And that also, the flip side means that the string copies are likely to fit in the small string optimization, so they're going to be free as well. But if string 1 and string 2 were huge, if they were like DNA sequences rather than dictionary words, then suddenly the n squared is going to become a little bit terrifying, and it may well be that the copy approach is actually superior. But anyway, that was something I was hoping to have a bit of a discussion with. But what I want to leave you with is something that Ollie and Tom and I had some fun with at a C++ London meetup a couple of months ago. And so here's what I want you to do while we're away. Sorry, the background's gone horrible. But I highly encourage you to come along on Thursday and have a go at this, because it's a really, really, really good exercise. So I want you to write a function just called toRoman. It takes an int and returns you a string that contains that int, so a positive integer. So you don't have to worry about 0, you don't have to worry about negative numbers. Strictly positive integer that I want you to write that in Roman numerals.
This will interview like a take-home exercise like a relatively trivial one. Like I've had one for been
Okay. Well, this was supposed to be a bit more taxing than the last two. It was, yeah. So,
But abstract, you know, kind of like exercises that are a bit more involved.
yeah. So I'll leave you with that. That's it for today. We've 5 minutes over, so apologies for that. But thank you everybody for coming. I hope today has been an interesting session. It was certainly interesting seeing you all work through that little problem with the summits. We're off to the pub as always. Next week we will be talking about test-driven development. In fact, Oliver will be talking about test-driven development, I hope. So that's going to be our next module. We're going to do, 6 weeks or so on that?
Programming for probably 5, 6 weeks.
5, 6 weeks on that, which is going to be great. Next week we are at...
Next week we are in the first week in Wasabi. Then I'll have to see.
Okay, but check the website. It's always on there. Thank you, everybody.
Thank you
and
much to Tristan for really well.
that's it from me.
Class. If I could ask you to make sure that the place is spotless clean.